All right, so this is about Smartstack. Let's get right into it. So I'm Patrick. I do systems engineering at a company called Get Your Guide in Berlin. I brought two minions here, and we do a website that sells guide services in many countries. So Smartstack is originally a project that was developed at Airbnb when I worked there last year, and it's open source. It's been open sourced in last November, and oh, sorry. Am I good there? Great. Even more here? Great. And I ported it at Get Your Guide to use it too, so I'll talk about this project. So I'm going to explain why we use Smartstack, give you an overview, what the original Smartstack uses Zookeeper, so what was changed to be using Serf, which is another service registration system, and some examples, and some time for Q&A. And also even installed a little Vagrant machine, and I can show you how it actually really works, like live, if you have any questions. So the whole premise of that is service discovery. So we all have used some of the methods, maybe all of them, with more or less success. You just start, there's one server, I connect to localhost. Then you start having many services. You maybe use a host file that you change, like, oh, my database master goes to another service or to another machine. And then it can become slightly more complex. So you might try and use DNS. Then you realize, ooh, you have TTL problems, so it just gets inconsistent. Some servers will go on one side, some on the other, so that really doesn't work. You can use a load balancer, which is super expensive. Lots of manual configuration is needed, so it's just a real pain. Or another solution, like they use, I think, at Twitter and the whole Twitter Commons library and stuff, is they actually will directly register in Zookeeper, and then it's the app that's the different modules that are aware of connecting onto of where they're connecting. So Smartstack alleviate this problem. That's, yeah. And so Smartstack is basically a registration service, but instead of having that done in the app or anything else, there's a local HAProxy. So you just connect to localhost, and it goes back to the rest. And it uses, yeah, here's the whole diagram, how it works. I'll explain the diagram. So we got, damn, this is not working. Here we go. We got the service 2 that wants to consume service 1. All it knows is a port number, which can even be configured itself through Chef or whatever. It's a static port number. Then it connects a local HAProxy that knows where to consume it. And this is configured like the first service will be proed by Nerve, which is the first daemon, announces it. The other one discovers it and reconfigures the HAProxy. And if anything goes down, imagine box 1, there are like dozens of them and maybe dozens on the other side. And it all reconfigures itself on its own. So yeah, Nerve, just the hard part is really to remember the names. Nerve probes the services. And Synapse actually reads from the registration and configures HAProxy. And the apps just talk to HAProxy. So back to the diagram, second time. So Nerve probes, Synapse discovers, and it goes through. So the big change we did at Get Your Guide is that the original system registers the service in Zookeeper. So while the Zookeeper is all nice and stuff, but it requires 3 or 5 dedicated servers to get a quorum. It doesn't support properly network splits or split brain. It's just really hard to manage. Whereas Serf, it's just a little binary. You run it 1 on each server, and there's no master. You just have to know at least 1 initial server to connect to. So we just put 3 of them, and hopefully at least 1 of the 3 will be up. Otherwise, we're in big trouble anyway. And yeah, it's also encrypted, whereas with Zookeeper you need to, it's not encrypted, and you need to firewall everything. Not that we don't, but yeah. And yeah, so that's really all there is. So we just patched the initial code from Airbnb, because that was also open source, and then put it to our own repository, and maybe at some point we'll go back to the master repo. So yeah, so what changed in this one is just the registration service is now Serf, which means no centralized thing. And we've had that in production for a while. So yeah, this stuff, it's just 2 JSON files, one for Nerve, one for Synapse. We distribute them through Chef, so it's just a little Chef recipe, which is also completely open source. And it's stable. It's been used all through 2013 at Airbnb. It was open source in November. And since I've been working at Get Your Guide, it was actually just a hack day project. Hey, I'll port that to use Serf. And well, it's been in production since like 2 weeks after. And we're really happy about it. We had some servers that just because we don't use Amazon, we use physical servers. We had some servers that just crashed on the weekend and this and that. And it was like, oh, it crashed, who cares? We'll just reboot it or get a new one or provision it or whatever. And there was no problems. And what's written in Ruby, so that makes it really easy. And if anything goes wrong, that's the other nice point. Like, say your probe scripts don't work properly, or this or that, or anything, it's still just HAProxy, which is very reliable. In the last 10 years, I don't think we've ever seen a single crash of HAProxy. And it does its own health checks in case, like if we have a split brain network, it will actually not try and connect to the wrong stuff, at least what it can't get to. And yeah, so because of HAProxy, we have all the HAProxy status page. I can show you that at the end. The config file we can log. The actual logs of the 2 little daemons are very verbose. And if you want to, you can just turn the logs to debug and see everything. They basically just probe, register in Serf, and probe again and cycle. And that's just about it. And yeah, it's super simple. I did 2, yeah, it was on Friday afternoons, maybe, yeah, an hour training, at least a half an hour of beer drinking, so within a couple hours, maybe it was really comfortable. And yeah, I'm not that good. So I'm not too good at all, actually. But yeah, so it's so simple. And at Get Your Guide, so here's some examples. At Get Your Guide, we use it to announce our MySQL slaves. We use it for our Elasticsearch servers. We use it, yeah, it's just for anything. And there are even more out-of-the-box examples. For example, we probe the web servers to the load balancer machines. And then on there, we have an Nginx configuration that just connects to localhost. And that way, web servers also go in and out for the whole system. And yeah, there's another little patch for cookie for load balancing. And the other one that's even a lot more out of the box is that for memcache servers, we don't want to use HAProxy because of circular hash and consistent keys, that kind of stuff. We don't want round robin. So we actually can read directly the output of Serf, generates a JSON, and we can choose our memcache servers from there. So yeah, that's about it, and I can do lots of demos and Q&A then. So we're Get Your Guide, we're hiring, including people to help me with this, and also PHP developers, front end, all that stuff. All this is open sourced on our Get Your Guide GitHub repo. There's our fork of Nerve, of Synapse. The patch is actually really small, like just a couple, maybe 100 lines each. And there's a Smartstack demo, which contains a full Vagrant file. You just download the repo, do Vagrant up, you're done. And a handbook that gives lots of examples. Originally, it was just supposed to be an internal documentation, but we figured, why not just publish it? And I'm Patrick at Get Your Guide. And that's some for Q&A. Yeah, I got a microphone here.
actually have a question, which is how does it scale in a many-to-many relationship? Like you have 20 of service 1 and 50 of service 2. And do you then have 50 times a local HAProxy that load balances over all 20 of service 1?
The answer is yes.
Okay, and are there any interferences by having 50 HAProxy instances deciding how to load balance over those 20 services?
It's a very good question. So to that, the answer is that the probes, there are actually two sorts of probes. The nerve probes a full health check, because it's only local to the machine, so it can probe something that can run for maybe a whole second or whatever, that might do slightly heavy checks, and then announces it to Serf or Zookeeper or whatever you choose to use. And whereas the probe of HAProxy can be another URL, just a little /ping or something. It's more of just a wall connectivity check than a real heavy health probe. And in my experience, it scales really well to hundreds and hundreds of servers.
I meant more like, do you have some kind of adaptive load balancing in HAProxy, like whatever, load-based load balancing, or is it just some dumb round-robin load balancing? Or
yeah,
that's what I meant.
Oh, okay. Well, the default thing is to just use round-robin. So yeah, it does mean that you would have identical machines, which well, originally was developed at Airbnb where all the machines are identical, and we kept the same thing at Get Your Guide to have more or less identical power machines. If you want, you can just set actually any HAProxy configuration you want, which is really nice. So let's zoom in, and I can show you that. Chef, cookbooks, Smartstack, attributes. Into, say, yeah, the services. It's big enough. I might even zoom even more. Okay. So here we can basically put any HAProxy options. So here you see there's mode TCP, timeout, connect, whatever. You can just add the load balancing mod. So the default is round robin. It can be source IP based. It can be with different algorithms.
Source IP is localhost.
Very true. So maybe desktop, I don't know, like whichever key. Like in the case of Memcache, we didn't actually, we only used the discovery part, and then it was the app that chose.
Okay. Sorry, next question. Did you notice any latency increase by adding the HAProxy layer as opposed to direct communication?
There's always a small latency with HAProxy. In what I've measured, the actual impact on performance is less than 0.1%. Like it's never visible. The actual HAProxy CPU usage is always extremely low, even with very high throughput, like gigs per second. It really stays very low. So I haven't seen any real drawbacks. It's slightly, like it can be maybe a bit confusing sometimes if you have several HAProxies and that might have a slightly different view of the system. But if the network is consistent and the configuration is distributed through Chef, it will most likely be consistent. But it's in that way, it will be best effort. Yeah.
It's a very nice thing. Can you say to how many nodes this solution scales out?
Well,
like
up to now,
thousands?
Yeah. Well, up to now, it's been tested to about 700. A bunch. Maybe 50 services that each had between 10 and 200 nodes. So it's in thousands.
Cool.
And yeah, it's completely open source, and I can also show the actual status page and the configuration. So I have a extremely basic configuration. So if any of you know Chef, I have a first one that has in demo it just does install of Memcache and MySQL with nothing in them, and I'm announcing through Nerve the SQL slave and the Memcache. And then the other server knows about it. So Vagrant SSH. I actually probably already have it here. Whoop. Box 1. So here we only have 2 members. So the first one has the tag that's smart memcache. I'll put it a bit higher. There we go. Yeah, it has a smart memcache with the IP and port. It announced these 2 services, and the other one announces this one. And if you look at the actual HAProxy configuration, which is on the other one, I'll have to zoom in too. Repo Smartstack demo, Vagrant SSH box 2. By the way, Serf is written by the same person as who wrote Vagrant. It's the same group, same company. And here we have our actual HAProxy.conf that corresponds to this. I'll move it around. So it's detected to have this one, these 2 here, and only one has, I think, the memcache. Actually, not at all right now. And memcache, yeah, it's supposed to listen. Anyway, so I did that one, and we can see, here it is, the status page. So we actually have the service. So I'll, for example, I'll just turn off here the MySQL in box 1. So we'll see it go down pretty quick. I think it's 3. Here we go. It's already gone. And if we reload the page, it's off. And it doesn't actually restart HAProxy if it's deleting something. It just puts it in maintenance state. Just uses the HAProxy socket. That way it's even lighter and you can still see it. And and if it comes back, I think it's also configured to 3 probes. Start. Going up. And it's there. Any other questions? Ah, yeah.
One more question. You mentioned when you add new service providers, so they will get auto-discovered.
Yeah.
And do you also do auto-discovering? So when you just throw away virtual machines, for example, you want to remove them also from the HAProxy file?
They effectively disappear. Serf detects when a member is out, and as a result, it will go out. Initially, it just goes in maintenance, but if you ever add anything, it will do a full restart of HAProxy. So the config file is also rewritten, and I can actually demonstrate that. So here we have box 1, box 2. I'll just do sv stop serf. So now it's actually stopped. Yeah, sorry, I'm in the wrong window. And now if I did it on, yeah, box 1, so if on box 2, now if I do serf members, it's counted as failed. I also have a JSON file that contains exactly this, the same thing. It's parsable. And in HAProxy, we see in the config it went away. And also, it's in maintenance here. So that's because if I turn on the machine. But if I actually restart HAProxy for any reason, it will completely disappear, which is done every now and then. Here you go. And yeah, so it's time you add a node because you couldn't put if a node goes away, you can do maintenance. If you're adding a node, you can't, so you have to restart it, which is seamless, but yeah. And yeah, so here, if I actually re-add it, it will restart it effectively. We can see here, uptime is 23 seconds. If I do here, now if I restart my Serf daemon, it takes about 5 seconds to start because I do a default Amazon probe in case we're on Amazon to get the local IP address, which is not the same one as the public IP address. Oh, here we go. And it appeared, and we see it's effectively started only 9 seconds ago, so it did do a restart. Any other questions? Thank you. Oh no, I'm not. I thought it was attached by a cable. It's weird. Any other questions?
So Serf is running on each instance, or you have a
Yes.
Serf cluster?
No, there's no Serf cluster. That's the whole beauty of it. It uses a gossip protocol, which is based on work, I think, from Cornell University. And it's written in Go. It's extremely lightweight. I've never seen it go over like 0.1% CPU or whatever. And I've only scaled Serf to a couple hundred machines, but I have no doubt it could scale to a lot more.
Okay, so every box has a Serf process running and an HAProxy process running?
Yes, and if it announces something, it has nerve. And if it consumes something, it has synapse. And I choose what it announces and what it consumes just with the little config file. Sorry, I wanted to put Control D, and I did Command D. Here we go. Yeah, so the box one effectively announces LCO11 memcache, and the other one effectively has both, which is why right now for this demo I only install it on the second one, the Synapse part.
And do Nerve and Synapse actually probe the application that you deploy there? Yeah. They do.
So I'll get back to the little drawing. Yeah, it's always the names Nerve and Synapse. I don't know what was chosen like that. It's always a bit confusing, but
the question what I want to ask is, did you ever experience, like, I mean, something could go wrong with Nerve and Synapse, right?
Mm-hmm.
So how do you detect that this script is not properly working? So from their outside monitoring, like the SQL server is up, but some hosts don't see it or whatever.
Okay.
Did you experience this, or is it just?
Particularly hosted at Amazon, that will happen to have some split networks, split brain network. So Nerve does the probe, which can be like whatever you want. You can write it yourself. You can do a TCP probe. You can run a script. You can do an HTTP probe. Well, basically, that's the 4 probes. And so it can do a big one, like if it's a MySQL slave, it can check that it's actually really active as a slave, or how many seconds behind the master, or whatnot. And it announces it. And yeah, the HAProxy will only do like just a TCP probe or something really simple like that. So if it's split, we accept that it will be maybe slightly inconsistent. Because there are always these, like you can have availability, you can have I think it's like availability, consistency, and I forget what and which one? And persistence, yes, and you can only have 2 of them. So in this case, it's persistence and availability, but consistency can be slightly off. Hopefully, it's not going to go too bad. Usually, you can, even if it's like an order and stuff, 1 call of customer service and you're okay. Whereas if it's down, well, it's no orders, so you can't even solve them. But yeah, it's always a trade-off. Questions? Okay. No? Yes? Thank you.
Okay. Now actually